Other ways to establish similarity in triangles is when triangles come together. In other words, superimposed or sharing a common angle. Here, triangle ABC shares angle B with triangles DBE. This figure may be seen in two distinct ways, as two triangles as stated previously, or as a triangle which has been transversed by a line parallel to the base. In any case, the results are the same. The parts of the triangles are proportional. But remember that in both cases segment BE must be parallel to the base. This is also of course true if we do it with any of the three sides of the triangle, and conditional statements are true. If the parts are proportional, the triangles are similar. If the triangles are similar, the parts are proportional. As a matter of fact, we may take a triangle and transverse it as many times as we want. As long as the line cutting the triangles are parallel, the parts it cuts are proportional. As a good extension of this reasoning, if the line cutting the triangle passes through the midpoints of the two sides of the larger triangle, then the segment that forms the smaller triangle is half the base of the larger triangle. Of course, this makes sense, because now the ratio of the smaller triangle to the larger triangle is 1:2. This condition about corresponding sides applies to all parts of triangles once you determine that the triangles are similar. For example, the perimeters, medians, altitudes, and angle bisectors of similar triangles are proportional. Let's see some examples. In this example, we have to find the value for x that would make the lines parallel. The value, of course, would be proportional to the known values. According to what we know, if the lines are parallel, then the parts AE and CE are proportional to parts AD and BD, where x is AD. So we set up ratios AE is to CE and x is to BD, where AE is 6, CE is 16, and BD is 24. Solving for x, we cross multiply 6 times 24, which is 144. The result we divide by 16. 144 divided by 16 is 9. X is 9. In the next example, we have to find the values for x and y, considering that they form part of three triangles that are similar. By now we know that for the triangles to be similar, the lines have to be parallel, and that parallelism comes from parts being proportional, so that 14 is to 12 as x is to 27. This will give us the value for x that would make the two top triangles similar. We cross multiply 14 and 27 and divide the results by 12. We get 31.5. To make the top two triangles similar, x has to be 31.5. Now to find y. To find y, we set up the proportion corresponding to the value 10, because 10 is corresponding to y. So 12 is to 10 as 27 is to y. Multiplying across, 10 times 27 is 270. 270 divided by 12, y is 22.5. The larger triangle is also similar if y is 22.5.